All right, question number 5, they ask us to find x if the perimeter of TUR, which is the big triangle, is 74, and then they want us to figure out if RE is perpendicular to TU. I'm not going to mess with that second part. I'm just going to mess with the equation first of all. So the sides need to add up to 74. So we've got a 2x plus 8, and we're going to add a 5x minus 1, and we're going to add a 6x plus 5, and we're going to add an x plus 20. And let's see, 2x plus 5x is 7x plus 6x is 13x plus x is 14x. 8 minus 1 is 7. 7 plus 5 is 12. 12 plus 20 is 32. Okay, so it looks like when we add all this up, it looks like we end up with 14x plus 32, if I did that correct. And that perimeter needs to add up to be 74. So I'll subtract 32 on both sides. We get 14x is equal to 42. If you divide both sides by 14, you get x equals 3. Okay, now the last part asks us if the lines are perpendicular. I'm not real sure what's going on with that, but I can at least find the side lengths. So if x is 3, let's fill in these sides. 2 times 3 is 6, plus 8 is 14. If x is 3 here, 5 times 3 is 15, minus 1 is 14. 6 times 3 is 18. 18 plus 5 is 23. 3 plus 20 is 23. Okay, so what you can see here is this is an isosceles triangle. We've got 2 lengths of 23, we've got 2 lengths of 14. There's also a shared side there. So these two triangles are congruent to each other, and we're trying to tell if these lines are perpendicular here. Well, those two angles would be congruent, and they're forming a straight angle. So if angles are congruent and supplementary, they have to be right angles. And actually, that's the answer to number 10, right? Angles that are congruent and supplementary. They have to add up to 180 degrees, and they have to be equal. They have to be 90-degree angles, right? So yes, those are 90-degree angles there, and yes, they are perpendicular to each other. Okay. Number 6, we have a median. They give us the measure of MDE, which is 5x. It's kind of a small diagram. Let's see if we can draw this again. All right. MDE here is 5x, and MDI is 4x. And already I'm seeing a straight angle there. We have 9 x's adding up to 180 degrees, so x is going to be 20. That might be helpful. They tell me the ED has a length of 3y, and DI has a length of 7y minus 4. Now this is one where I might want to use the original picture because my picture is not drawn to scale. If MD is a median goes to the midpoint of a side, so that means that 3y is going to be equal to the 7y minus 4, and we could solve that equation. Subtract 3y from both sides, add 4 to both sides. You're going to get 4y is equal to 4, so y is going to be equal to 1. And so they want the sum of x and y. Well, y is 1, and x was 20, so they're going to add up to 21, right? Choice A. All right, number 7. It's a perimeter of 30. The length of RT is twice that of RE. Not drawn to scale. Not drawn to scale at all. So that means this length is going to be x, and they're saying the length of RT is twice that length. That would be 2x. If that bothers you, you might want to relabel your picture a little bit. But anyway, notice there we have 6 x's adding up to equal a total perimeter of 30. So x is going to be 5. And then they want us to find the length of RE. Well, RE is x, so that's going to be a length of 5. And they want the area of the rectangle. So we have a base of 5, and we have a height of 10. 5 times 10 is, of course, 50 square units. All right, given the points negative 4k and k7, we want to find out a way to make that slope 2/3. Well, we have a formula for slope, right? y2 minus y1 over x2 minus x1. Not real sure what's going on here, but let's pop those points in there and let's see what happens. So I'm going to take my second y minus my first y. That's going to be 7 minus k. I take my second x minus my first x. It's going to be k minus negative 4. So I get 7 minus k on top. I get k plus 4 on the bottom, and I want that to equal 2/3. So a little bit of algebra 1 here. We have a proportion. And if you have two fractions that are equal, called a proportion, the cross products will be equal. So the cross product this way, 3 times 7 is 21. 3 times negative k is negative 3k. Should be equal to the cross product going the other way. It's 2k plus 8. Move the k over here, we get a 5k, subtract 8 from both sides. 21 minus 8 is at 13. So it looks like k is going to be equal to 13/5, which I don't love because it's not going to be real easy to check. But let's go ahead and just check that and just see if that's actually right. So if k is 13/5, and by the way, if you want a decimal here, 13/5 is about 2.6. So I just want to check here and see, is 7 minus 2.6 over 2.6 plus 4, does that really work out to be about 2/3? So 7 minus 2.6 is 4.4, and 2.6 plus 4 is 6.6. And yeah, I think if you divide out 2.2 from both of those, that is in fact going to be equal to 2/3. So yeah, this checks out. Wow, there we go. All right, last one on this page. Are these points collinear? Remember, collinear lines or collinear points have the same slope. So you may want to make a quick sketch of what this might look like. So we've got 1, 2, we've got 4, 6, and we've got 10, 15, which will be up here somewhere. The important thing is not that this is drawn to scale. It's not a measurement problem. We don't want to assume anything. But basically, we're just trying to look and see, is this slope the same as that slope? If the slopes are the same, then they're in a straight line. If the slopes are different, they're not in a straight line. So I'll do the slope of this segment here first. y2 minus y1, 15 minus 6 over x2 minus x1. And that's going to be 9 over 6, which is equal to 3/2. Make sure you simplify because you've got to compare your slopes. And then for your second slope, 6 minus 2 and 4 minus 1. And so we get 4 over 3. And no, those are not the same slope. So you basically have a situation where one is sloping one way and one is sloping a slightly different way, and it's not going to be a straight line. All right?